Okay, this is the experiment P15 and characteristics of valves. This experiment including 4 stages. The first one is investigation of the flow and the pressure characteristics of one kind of valves. And the stage 2 and stage 3 we will change. We are going to investigate the different kinds of valves. And then the stage 4 we are going to investigate one of the characteristics of these 3 valves, so that we have 4 stages. And the first one, second one, and the third one, we will repeat all the procedures for 3 different kinds of valves. And then the stage 4, we are going to investigate all these 3 kinds of valves altogether. Stage 1, investigation of the flows and pressure characteristics. Okay, first we will make use of a test rig, this one. Okay, and we will first to run the pumps and to make sure all the water fill up all the pipes, and to no air bubbles inside the pipes. Okay, and then we are going to count the valve characteristic by turning the valves to see how many turns associated in the testing valves. And then we are going to fully open the valves, and then we are going to take the pressure sensor, and then we are going to make the pressure sample nice so that there's no air trapped in there. I will show you the procedure later on. And the step number 6, start to monitor by the software and all the data files. And then we are going to run the pump, start the pump to the full speed. And then we are going to measure the pressure differential across the valves. All the readings, we are going to record all the readings after the study. With the software still running, we are now to change the actuator which will control the pump running at different positions from 1 to 10. And then we are going to record the differential pressure and the flow rate. And then finally we are going to repeat all the procedures until we complete all the actuator position. Okay, here is the software. We are going to use the software SET AFTC. Here is the software. The software will indicate the schematic diagram of the setup, and we are going to investigate 3 valves. One is the in-kind city valve, showing there, and then the second one is the gate valve, and then the third one is the membrane valve. And we do have one set of pressure differential, SPDA2 A and B, with a differential pressure, and the differential pressure will be shown at the SPD2. And we have one flow meter here, and the reading will be shown at the SC1. Okay. Here's the main control of the setup, and now we can turn it on. Here is the in-kind angle city valves. These 2 are the differential pressure sensor, SPD2A and SPD2B. We make the line open and all other valves of other bypassing line making close. By turning the anti-clockwise fully and make the valves fully open. Okay, we check all the valves. Here are closed and this one open. Here, this one is a flow sensor. Okay. Now the actuators. Here's the actuators. and the actuator control. And then we put start. Okay. Now the pump open. We have a several bubbles there. We need to purge the system so that we can remove all the bubbles. For all the settings, we need to observe the flow meter if there are flow inside the pipe. So we need to run the system until all the air bubbles remove. Okay, the next, here is the sensor. The sensor here is on off. Okay, and the sensor plugged into the sensing point. Okay, and then we need to purge all the air locked in the pipes. In the corresponding tube, there's an SPD2, the sensor purging. We open the valves until all the bubbles come out, all the water for both sensor tubes. We have to make sure no air bubbles locked inside the tube. Okay. Now for the stage 1, 2, and 3. Item number 7. Run the pump at the full speed, which the actuator at 10. Enter. The graph showing here is the graph B. It's the flow rate. Is the flow rate. The flow rate showing there. So the first reading, the sensor SPD 2A and 2B, and the calculated differential pressure against the flow rate. So we record down all these numbers, and then step number 9, repeat the previous step. Round 1 by 9, actuator 9, enter, and then we can observe the flow rates decrease, and we need to wait around half a minute to reach a steady state. So that the next reading we are going to record is the differential pressure and the flow rate. And we repeat all this procedure. 8, 7, 6, 5, 4, 3, 2, 1. For the flow rate very small, for example 1, okay, the reading is minus and the flow rate is minus. However, we need to observe the flow meter. Actually, the flow is so small, the flow meter cannot give you a reading. Okay, so that we have completed the stage 1, and then we are going to repeat all the procedure for other 2 valves. Okay, when we going to test the other valves, we need to move out the sensor, plug into the gate valves to repeat the measurements. But remember, you need to purge the tubes for all the air bubbles. And then complete the second one. We are going to use the third one, the membrane valve. Once you complete all this, we are going to investigate the stage 4. The stage 4 determination of adherence characteristic for each valve type at a constant pressure. So we first start at the maximum flow rate. After it reaches the steady state, we are going to record down the differential pressure. Now it's around 185 or 190 around. Okay. Then the next step, we are going to close down the valves by some turn. The valve now is fully open. We have already marked the marks over there to indicate the number of turns. And for this valve, every time we will move down by 1 turn. And if you are going to investigate for the gate valve, each time we will downturn by quarter. For the membrane valve, each time we downturn by half turn. And we also mark the marks over there to indicate the number of turns. Here and here. Okay. Now we turn it down by 1 turn. 1 turn. Okay. Now we are going to see the reading. Around no change. So we record down the pressure, differential, and the flow rate. We are going to repeat the procedure. Two turns, and then go to get measurement, and then 3 turns to get the measurements. Okay, 2 turns, 3 turns to get the measurements is from there. We look at the pressure, still no change, and the flow rate. All right, and then supposingly we each time down by 1 turn. Okay, we look at the pressure. Now the pressure is higher, differential pressure. Our original one is 190. So we are going to down tune the actuator in order to have the same differential pressure, 190. Okay, we are going to adjust the actuators so that the differential pressure is around 190. At this level, we record down the number of for the number of turns and the flow rate. Okay, so that we are going to repeat this procedure until the valves got no flow rate. All right. After that, we need to now the valves are fully closed. Finally, one more data we need in order to have a calculation. We look at the marks. Here is 0.9 approximately, and then we need to count how many turns from fully closed to fully open. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13.9. Around 14. Okay, and then we are going to record all the data for all the stages. We are going to repeat the stage 4 for all 3 valves type. Okay, by the measurements, here is the data. Stage 1 for the in-kind seat valves, actuator position, the flow rate, and the differential pressure. Stage 2, gauge valve. Stage 3, membranes valve. And the stage 4, we are going to maintain the same differential pressure by adjusting the actuator at each of the turns, at each of the turns of the valve's position, and then we have the corresponding flow rate. For the in-kind seat valves, gauge valve, and the membranes valve. The data there for the full turn from fully closed to the fully open for the in-kind seat valve is 14.5 turns, gauge valve 4.1 turns, and the membranes valve is 5.4 turns. Here are the data.